Hello, today we're going to look at how we can use the quadratic formula in order to solve quadratic equations. In the past, you've seen how we can use factoring and the zero product property in order to rewrite quadratic expressions in factored form. However, sometimes that won't always work. Sometimes we can't find whole numbers that can work in order to create factors that are equivalent to our quadratic equation in standard form. Today we're going to learn that some methods for solving quadratic equations can be more convenient than others. That is, factoring is usually the best option, but if you find out that a quadratic isn't factorable, then we will use the quadratic formula. We also are going to look at application problems, and so it's going to be important that we can interpret the solutions to a quadratic equation in terms of a situation so that we know what our answers mean. First, we're going to take a look at this warm-up. Each expression here represents two numbers. So that means that our plus or minus right here means that there's two options. This is going to mean both 1 plus the square root of 49, and then another option also, which is 1 minus the square root of 49. Take a moment to evaluate each of these expressions. Looking at the first one, remember that this means both 1 plus the square root of 49, which equals 1 plus 7, because the square root of 49 is 7, and that's going to be 8. But we're not done. Because of this plus or minus, we're going to have another solution also, 1 minus the square root of 49, which means 1 minus 7, where we get -6. The next question, we have the same plus or minus, but we also have a fraction, 8 plus or minus 2, all divided by 5. So this means that we have one of our solutions will be 8 plus 2 over 5. 8 plus 2 is 10. And 10 over 5, remember that fractions mean the same as division, so 10 divided by 5 is 2. 2 will be one of our answers for evaluating this expression, because we also need to write 8 minus 2 over 5. This is going to be our second possible answer. 8 minus 2 is 6, so we have 6 over 5. You can leave your answer like that, or you could also write it as 1 and 1/5. Either of those is okay. So notice that for both number 1 and number 2, we had two answers because of this plus or minus in the original expression. Later, when we're working with the quadratic formula, we're going to see several different expressions that look kind of like this. So we also want to practice what happens if we have the plus or minus in front of an expression that has our square root. So one option is that this is going to be a positive. So we'll use the positive version where we have a positive -5 squared minus 4 times 4 times 1. When I write this, I'm going to make sure that I make it clear where my square root symbol starts and stops so that I know what's included in that. As I evaluate this next, I'm going to do my exponents, -5 squared. Make sure we know that the parentheses include this negative. So we have -5 times -5, which gives a positive 25, minus, then 4 times 4 is 16, times 1 leaves us with 16. So here we have the square root of 9. The square root of 9 is equal to 3. Another option here, our second And we need always to find both options. Our second possible answer for evaluating this comes from using the negative from our plus or minus. So here we have the minus, and then the same expression, negative 5 in parentheses squared minus 4 times 1. Again, I'm going to be careful with my square root sign so I know what is and isn't in our radical or square root symbol. I want to remember this negative from the front of the expression. But again, I'm going to have 25 coming from negative 5 times negative 5. So 25 minus 4 times 1 is 16. And once again, I have the square root of 9, but we have a negative in front. So this answer is negative 3. All right, so question 1, our answers were 8 and negative 6. Question 2, our answers were 2, 6 over 5. Question 3, our answers were 3 and negative 3. We're also going to see what happens for number 4, where this is kind of combining a lot of the stuff where we're having an addition and subtraction, we're having a fraction. So let's take a look at what we get. I'm actually going to simplify this a little bit first before I use my plus or minus. Actually, no, I'm not. That's more confusing. Let's do it this way. All right, negative 18 plus the square root of 36. You need to remember that that's over 2. Let's see. 2 times 3. So negative 18 plus, and then the square root of 36 is 6 because 6 squared equals 36. 2 times 3 is equal to 6. So now we have negative 12 over 6. Remember that our fraction means division of the numerator divided by the denominator. So we get negative 2. Remember as well that we need to use the minus version of this. This doesn't mean that anything about this sign in front of the 18 is going to change. That's still going to be a minus. But in this space where we have the plus or minus symbol, now we're going to write the minus version. So negative 18 minus square root of 36 over 2 times 3. Which means we have negative 18, and this time it's subtracting 6 over 6. Both the negative 18 and the 6 are negative. We're combining two negatives, so we have negative 24 over 6, and a negative divided by a positive is negative, and 24 divided by 6 is 4. So we have negative 2 and negative 4 are the two answers for question number 4. So just to do kind of a quick check-in about how we could write this, we could also write our two answers as negative 6 and 8. So putting it all together, remembering that we have two solutions. For number 2, our answers were 6/5 and 2. For number 3, our answers were negative 3 and positive 3. And for the last one, we have negative 4 and negative 2. You may be wondering why I flipped the order on some of these. This is just a convention. It's not a rule, but just kind of a pattern that people follow of usually putting the lesser answer first. So negative 6, and then writing and 8, since 8 is greater. But it's not going to be marked wrong if you put them in another order, because both of those are correct solutions. All right, so now we're going to look at how the quadratic formula can help us. This formula is called the quadratic formula. And if we have, so this formula can be used to find the solutions to any quadratic equation in the form ax squared plus bx plus c equals 0. So remember that that's standard form, where a, b, and c are numbers, and a is not equal to 0. Remember that if a were 0, and we just had bx plus c equals 0, that would be a linear function. So with quadratics, we're always working with a not being equal to 0, so that we actually have an x squared term. Okay, so this example below is going to show how we can use that quadratic formula in order to find solutions. So we have x squared minus 8x plus 15 equals 0. So the coefficient of the x squared is 1. The coefficient of the x is negative 8. And the coefficient of, or the constant term, is 15. And it's very important that this is in a form where it's already set equal to 0. We can only use the quadratic formula once we've got it in this standard form and then set equal to 0. So first we're going to have our original equation, the formula for quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to substitute in the values for b. So we have negative b, so the opposite of this negative 8, plus or minus the square root of b squared, which is negative 8. So negative 8 squared minus 4ac. So 4 times 1 times 15. And that's going to be divided by 2 times 1, 2 times a. When we start simplifying this, the opposite of negative 8 is positive 8. Negative 8 squared, so the parentheses include the minus sign here. So negative 8 times negative 8 is 64. 4 times 1 times 15 is 60. So we have the square root of 64 minus 60. So our solutions now are x equals 8 plus or minus the square root of 4 over 2. And once we start simplifying with the square root, we have the square root of 4 is equal to 2. And now this fact that we have the plus or minus means that we have two solutions here. We have 8 plus 2 over 2, which is 8 plus 2 is 10. Over 2 is 5. And we also have the other, very important that we include both solutions, 8 minus 2 over 2. So 8 minus 2 is 6 over 2. 6 divided by 2 is x equals 3. So our answers, we need to include both the 3 and the 5 are both solutions to this quadratic equation. So let's take a moment to set up number 1. I always like to write our quadratic formula so that I make sure I plug in everything correctly. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. A equals 1, b equals 4, and c equals negative 5. So now I have x equals the opposite of b, so negative 4, plus or minus the square root of b squared, so 4 squared minus 4 times a times c all over 2 times 1. negative 4 plus or minus the square root of 16. Let's write that a little neater. 16. And then minus 4 times minus 5, we have plus 20. We're going to end up dividing that by 2. So x equals negative 4 plus or minus the square root of 16 plus 20 is 36. So we have two possibilities here. We have negative 4 plus 6 over 2, which would be 2 over 2, which equals 1. Or we have negative 4 minus 6 over 2, which is negative 10 over 2, which is negative 5. So for number 1, our answers are negative 5 and 1. These are both solutions that if we plugged in negative 5 for x, this equation would be true. So our quadratic expression on the left would be equal to 0. And same for the 1. If we plug that in, we would also get a true equation here, or we would find that 1 is a solution or a value for x that makes this quadratic equation true. Let's try the next one. We always want to identify what our coefficients are, what the a, b, and c values are. A is 1, the coefficient of x squared is 1, b equals 7, the coefficient of the x is 7, and then our constant term that's being added here at the end is 12. It's important that before we write that these are a, b, and c, we make sure that it's in standard form. So it was set equal to 0. And now we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and just for fun, I'm actually going to let you know this is something that in a lot of Algebra 1 and Algebra 2 classes, teachers have often expected students to memorize this, and one tool for helping memorize that is a song that you'll probably hear people refer to. So one version of it, the most popular version, is to the tune of Pop Goes the Weasel. And so the song would be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And another version that I find kind of fun also is if you know Adele's song Rolling in the Deep, can have a little bit of musical fun with this. We go, it's negative b plus or minus square root of b squared minus 4ac all over 2a. So those are some options for helping you with remembering the quadratic formula if you ever find yourself in a class that is asking you to memorize that. Both of those songs just say 4ac. Make sure you remember that that's 4 times a times c. Same with the 2a, that means 2 times a. Let's go ahead and start plugging in some numbers. So negative 7 plus or minus the square root of b squared, so 7 squared, minus 4 times 1 times 12. Extend our square root sign so we know what's part of the square root symbol. And that isn't a straight line. Let's try that again. Here we go. All right, and over 2 times a, so 2 times 1. That means we've got x equals, oh, and look, I forgot my negative b. We have a negative 7. All right, so let's be careful with that. Negative 7 plus or minus And as we start to simplify the expression inside the square root, 7 squared is 49 minus 4 times 12, or 4 times 1 times 12. We're going to have minus 48 over 2 times 1, which is 2. So x equals, and as we start simplifying this a bit more, now we have negative 7 plus or minus, we have 49 minus 48 inside the radical or square root symbol. So we have the square root of 1, and that entire expression is divided by 2, or over 2. X equals negative 7 plus or minus the square root of 1 is 1. So we have our two different possible options. We have negative 7 plus 1 over 2, which is going to be negative 6 over 2, negative 3. We also want to include the solution where we have the minus from this plus or minus, negative 7 minus 1 over 2, negative 8 over 2, which is negative 4. So our two solutions, we need both of them. Our two solutions to number 2 are negative 4 and negative 3. Now remember, that means that if we plugged in negative 4 for x everywhere in this equation, that we would get a true equation, or we would get this quadratic expression equals 0. And same thing with the negative 3. A solution for x means that that's a value we could plug in for x that would make this equation true. So what's the point of all of that? Why do we even want to solve these quadratic equations? Well, in a lot of cases, there's word problems. In the real world, the quadratic formula shows up, or quadratic equations show up, for instance, when we're working with problems that have projectiles, or things being thrown or launched or dropped. So we're going to take a look at the potato. In a previous lesson, you looked at launching a potato. Our question here is the equation h of t equals negative 16t squared plus 80t plus 64 represented the height in feet of a potato t seconds after it had been launched. So make sure that we know that we have h of t. Our function notation means time t seconds is our input, which is better referred to as our independent variable. And the height in feet is going to be what depends on that, so our dependent variable. So that means h of t in our function notation, h of t, height is depending on time. All right, so part A, first we want to write an equation that can be solved to find when the potato hits the ground. When something hits the ground, its height above the ground is going to be 0. So we're just going to take this entire equation and we're going to replace h of t with 0 because the height is 0. So 0 equals negative 16t squared plus 80t plus 64. All right, we're going to wait to solve the equation to the next slide. Question B asks us to write an equation that can be solved to find when the potato is 40 feet off the ground. So this means our height is 40 feet. Be really careful. This isn't seconds. We're not plugging this in for t. We're plugging this in or substituting this for h of t. So 40 feet is equal to our negative 16t squared plus 80t plus 64. All right, so 40 equals, and then our quadratic expression, because 40 is the output or the height after t seconds, and we want to find out what t is. Something important to know, if we look at this isn't in standard form because this isn't set equal to 0. So in order to use our quadratic formula, we want to make sure that we get it set equal to 0. And we can do that by subtracting 40. But in order to keep our equation balanced, we have to do that same operation on the other side of the equation as well. So negative 16t squared plus 80t, and then 64 minus 40 will be plus 24. Yep, I forgot the plus symbol. Okay, so these are the two equations for finding when it hits the ground and finding when it's 40 feet off the ground. Let's go ahead and use our quadratic formula to help us with solving this. We have in this first one, a equals negative 16, b equals 80, and c equals 64. Our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative b will be negative 80 plus or minus the square root of b squared, so 80 squared minus 4 times a, which is negative 16, c, which is 64. I'm going to be careful that my square root symbol includes all of that, because all that needs to be inside the square root symbol. And then 2 times our a value, which is negative 16. As we start simplifying this a bit, so we can evaluate and find those solutions, we have negative 80 plus or minus. And this, when we simplify this, we end up with 80 squared minus 4 times negative 16 times 64. I'm going to skip the showing all that multiplication. You can show those steps. You can also use a calculator for that. We should end up getting that we have negative 80 plus or minus the square root of 10,496. And all of this needs to be divided by negative 32. Now, in some cases, we would be expected to keep it in an exact form that has the square root and has everything exactly as a whole number, like we had seen in some previous cases. However, our answers here end up being decimals. So we have x equals negative 0.702 and x equals 5.70. Remember that we're getting two solutions because we're getting one from the negative 80 plus, and then we're getting one from the negative 80 minus. But in terms of when the potato hits the ground, we need to think about what's going on in this problem. If we had a parabola that has solutions, one of which is negative and one of which is positive. So we have a negative answer and a positive answer. This negative one doesn't really make sense because that means it was launched from a certain height, but then it only reaches the ground after 5.70 seconds. It doesn't make sense to say at time negative 0.702 it was on the ground, because that just isn't the case. It was launched from a height of our constant term 64, and negative time isn't going to make sense in this case. So the potato hits the ground 5.7 seconds after it is launched. Okay, and this would not be a complete solution if we just gave x equals negative 0.702 and x equals 5.70, because this is a word problem where we need to make sure that our response makes sense in context. This is also called interpreting the solution or solutions in terms of the real world context. Let's take a look at when the quadratic expression was equal to 40, or when we are 40 feet in the air. Remember that our negative 16t squared plus 80t plus 64 equals 40. We can't use the quadratic formula directly with these numbers, negative 16, 80, and 64, because it's not yet set equal to 0. We have to get our quadratic in standard form set equal to 0. But now that we have it that way, by subtracting 40 from both sides, we have a equals negative 16, b equals 80, the coefficient of the t, and then c equals 24. So here we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And when we plug in our values, we have negative b, so negative 80, plus or minus the square root of 80 squared minus 4 times negative 16 times the c value, which is 24, over 2 times our a value. So we get x equals negative 80 plus or minus. So that's going to give us, we're going to have to evaluate it both ways with the plus and with the minus. 80 squared minus 4 times negative 16 times 24 over negative 32. And again, sorry for not showing every step of simplifying this, but when we do simplify the 80 squared minus 4 times negative 16 times 24, when we do the addition and subtraction, and when we divide that by negative 32, we get x equals negative 0.284 and 5.284. Now, once again, sometimes both of these solutions would make sense. However, because we're looking at when it's 40 feet in the air and it was launched from an initial height of 64 feet, and we want to know when is it equal to a height of 40, that is, when is it 24 feet above where it started originally at 0, it doesn't make sense to say the time is equal to a negative value before it was launched. So the only answer that makes sense in this problem is saying 5.284. And visually, this is kind of like saying over here, if we were asking for when is it at a certain height of 40, and it doesn't really matter if it would have been at a height of 40 before launch, because this is when our story starts, is when it's launched at time 0. And then we look for when is it going to be 40 feet above the ground. Okay, so once again, this first solution doesn't work for the context of the problem. So we can say the potato going to do 5.284 seconds after it is launched. And that would be our answer, saying the solution or solutions that make sense in the problem, and then also saying what that solution or solutions mean. So in this example, we came up with two solutions to our quadratic equation, but only one of them made sense in the context of the problem. So when we're asked questions about real life or close to real life, so fake world is okay, but still with the gravity of Earth, we want to think about what actually makes sense for answering the question. Sometimes, even though we find two solutions, only one of them is reasonable for what the problem is asking. All right, you're going to get some practice with this by completing the cool down by midnight tonight and the Delta Math Unit 7 factoring and quadratic formula by midnight tomorrow. We also want to think about, if you look at the questions we did earlier, where we ended up with whole number solutions. There we go. This slide. Let's catch up. Come on. All right, here we go. In the first two examples of using the quadratic formula, we got whole numbers. So that means the quadratic formula will always work. But sometimes factoring would have been a little bit faster. If we had been able to find that this expression, x squared plus 7x plus 12, could be written as x plus 4 times x minus 3 equals 0, factoring would have been a little bit more efficient. But the quadratic formula will always work. So sometimes you get something that is factorable, so try factoring first. But then if you get something that's not factorable, or if you're not really sure you want to check if it's factorable, the quadratic formula will always work as long as you get it in standard form set equal to 0. All right, so once again, the cool down and the Delta Math practice. And remember to contact your teacher if you have any questions. Also with our Delta Math, remember that there are help videos. So when you are working on the Delta Math problems, you can click Watch Help Video. All right, that is all for today.